Okay, so I'm gonna go into the notes and we'll talk through some stuff with functions, and then I will go back through some of the stuff that we already talked about, Jimmy, and you can leave then so that you don't have to sit through it again. Okay, so chapter one is basically just a recap of what you should have learned in other courses leading up to mine. So let's go through some stuff in chapter one. Just the basic idea of a function. Hopefully we know what a function is. It's how one thing depends on others. So the example here is talking about you make $12 per hour. So how much money would you expect on your next paycheck? And then writing that as a function, you would write f of x equals 12 times x. The thing here is that f is the function name. X is the input value. So this x is just a placeholder. So we can put anything we wanted there. So on the next step, putting in 25. So f of 25 would be 12 times 25. And that's how functions work. One thing depends on another. Okay, so then this is more of that. So this is an important point. For each input, a function will produce exactly one output. That's the definition of a function. Every input has exactly one output. And graphically, that means that this function passes a vertical line test. Or if you were thinking about, I don't know, this is in one of my son's books. This is why this idea came to my brain. Just ignore me though, if it's stupid. So, you know, like this matching up like this would be a function. You'd have just one arrow coming from everything on the left. If instead this went like this, that would not be a function because you have two things coming from the triangle going to different things on the right. So we're thinking about it like this is a function, but this is not because it fails the vertical line test. This input value, whatever it is, say it's x equals -2, goes to both that top part of the circle, oval, and the bottom. Okay, so a relation is like a function, just less restrictions. So a relation is just a set of ordered pairs, and then a function is a special kind where every input has exactly one output. Okay, and the set of input values is called the domain. That's the x values. And then the range is the y values. So this is a thing just to practice again, the placeholder thing, f of 7. Here's our function f. This would be 2 times 7 plus 3, 14, and 3 is 17. And then f of x plus 1. You would do the same thing, just plug in the x plus 1 instead of x, and then distribute that 2. So you get 2x plus 2 is 3, so you get 2x plus 5. And then evaluating this from a table, remember the function from above is 2x plus 3. So f of 0 would be 2 times 0 plus 3, so that would be 3. 2 times 1 plus 3, that would be 5. 2 times 2 plus 3 would be 7. And then plotting that would look like this-ish. Plotting those ordered pairs. And so this is a function because it passes the vertical line test. It's a line. Okay. Talking more domain and range, describing these shaded values. So we include the -1, but not the 3. So that would look like -1 to 3, or -1 is less than or equal to x, which is less than 3. Either way, you could do that. This is interval notation. This would be my preferred method. This is set builder notation, which can get real messy real quick. Okay. Questions about any of that? We understand that the bracket is included. A parenthesis is not. Anytime you have infinity or negative infinity, you are going to use a parenthesis, because by nature of being infinite, you cannot reach it. So. Oh, good. Okay. And then if we could move on to this example, we have this function f of x, and we want to talk about the domain. So for me, I think left, right. So where does this function, if I'm coming along here, where do I start hitting my function? It would be right here. And then if I keep going, where do I stop? Oh, the function stops right here. So this is going to be my interval. So from -1 to 2, left to right, small to big. And if I look closely here, let's see. This is an open circle. This is closed. So the open circle is going to get a parenthesis. The closed circle will get a bracket. And that's the domain and interval notation. And then if we want to talk about the range, we're going to go bottom to top. So small to big again. And we want to look, if I'm traveling along here, where do I start hitting my function? It would be right here. And where do I stop hitting my function? That would be right here. So the values are going to be -1 to 3. And because this goes through here, that's basically a closed circle. This is a closed circle, so they'll both brackets. And then f of, let's see, a different color. Purple. F of 1 would be sitting right here. That is going to be 0. And when does f of x equal 3? So what you're going to do, I'm going to erase all of this stuff so we can see what's going on. When does f of x equal 3? What you're going to do is that's a y equals 3. So draw a horizontal line there and just see where your graph crosses it. So it crosses right here. What x value is that? It's 2. So f of 2 equals 3. If this went on over here, we would get another one of those, but it doesn't. So we don't. The x-intercepts, what is or are they? So x is equal to, x-intercepts, we're looking for where we cross the x-axis. So our points in question would be -1 and 1. But again, this is an open circle on the x-axis there is open, so it's not included. So our only x-intercept is this one right here. And the y-intercept, we're looking at where we cross the y-axis. That would be when y equals -1. Okay, any questions about that example? Good deal. I don't know how we're going to get all this on the same page. Here we go. So f of 4, we're looking when x is 4, what's the y value? It's 9. Where does, oh, I have to go in order. Where does f of x equal 2? So again, we're going to draw a horizontal line when y equals 2, figure out what x values make that true, and none of them do here. Where does none? That's not a good example. A good nowhere? Is that better? Okay. Where does f of x equal 10? You would do the same thing. Go to 10, draw a horizontal line, see where it crosses. That happens to be about 3 and 7, maybe. Yeah. Okay, and then the domain and interval notation. So we're going to start to way off on the left, move right until we are not touching the function anymore. This arrow pointing to the left forever means that our domain is going to start at -infinity. We're going to travel along our function until it stops. So we've got this gap right here when x is 2. So we're going to stop right there. It's not included. That's a vertical asymptote. So we'll leave it as a parenthesis. And then we'll pick back up at 2. And then we go off forever to the right. So that would be to positive infinity. And that would be the domain of that function. That is a function that passes the vertical line test because of that asymptote. So, any questions about that example? Okay. Now, I'm not going to have room to do this here. Solving this equation for y, I'll try to fit it in here. So I'm going to subtract that x term from both sides. And then I'm going to multiply by 4 on both sides. So I get y squared equals 4 times 1 minus x squared over 16. And then what I would do is a square root. When you take a square root, you have to include a plus or minus. You could do this differently. Y'all could distribute that, and there's just no need at this point. So there we have solved for y. And the important thing is, does this equation we've just written define a function? And the answer is no, because of this plus or minus. Any x value we put in, we would get a plus or minus y value. You can see that graphically. If we put in x equals 1, we would get, don't use 1 because those x values, okay. If we put in x equals 0, we would get y equals 2 and y equals negative 2. So when x is 0, y is plus or minus 2. That's a problem. That is our 0 going to 2 and 0 going to negative 2. We can't have two arrows coming from the same x value going to different y values. So this fails vertical line test is not a function. Okay, then I don't know how much of this we need to do. Let's see. I did function composition on the video example, so we don't necessarily need to talk about that. So let's just do this last page, and then we'll be done for this morning. So we have this function x squared minus 3. It's a parabola that's been with f of negative 1. That would be negative 2, and f of 1 is also negative 2. What's f of negative 2? That would be positive 1, and f of 2 is also positive 1. So here, f of negative 1 equals f of 1, and f of negative 2 equals f of 2. So when we change the sign of the input, nothing, the output doesn't change. So this is, if you're given f of negative x, that would mean that that equals f of x. That is an even function and has y-axis symmetry. This is covered in college algebra, so this should be foundational knowledge. But if you were to fold your graph along the y-axis, those pieces of the parabola would match up. And that means all those negative x values give you the same thing as all the positive y would. Positive x values, they give you the same y value. Sorry, that was horribly worded. The fact that these all match up everywhere means that this is an even function. That you like x squared, x to the 4th, x to the 6th, those are all basic even functions. That the squaring part of, if you plug in negative 1, you square negative 1, you get 1. And so that makes this an even function. If you could plug in negative x and get back to the original thing you started with. Should I show you that? Yeah, let's do that. For our function was x squared minus 3, so we would have negative x squared minus 3, which gives you x squared minus 3, because that negative doesn't matter when you square. And so this is the original function we started with, which means that that's an even function. Okay, this one's going to be odd if you could guess. We have 1/27 x cubed, and we would like to know what f of -1 is. It's right here, but 1/27 times -1 cubed, that would just be -1/27, and similarly, f of 1 would be 1/27. F of -3, you can look right here, that would be -1, and f of 3 is +1. So what you notice when you switch the sign of the input, the sign of the output changes. Let's write a sentence. And so what that means, you have f of -x, that will give you negative the thing you started with, and that's an odd function, and it has origin symmetry, meaning you fold first over one of the axes and then up over the other one. So let's suppose I folded over the x-axis first. I'm folding this piece down over the x-axis, and then I fold it over the y-axis. It would end up on the other piece of the graph. That's what it means to have origin symmetry, is that you flip over both axes, which means you're sort of flipping around the origin. And that negative on moving to the outside of the whole function is what makes that happen. So let's try that. We got -x, 1/27 times -x cubed. Since you're cubing, that negative is going to stick around, and you can just put it in front. This is negative f of x, making that an odd function. So any questions about even and odd functions? Or those even and odd functions? Okay, good. And like I said, function composition I went through in the video. The main thing that you should recognize here is I always make my students, if you've had me before, you know this, I make my students get rid of this symbol, this notation I do not like. I don't think it's very clear what's going on. So I make all my students rewrite it like this, because then you can see, okay, well, this is my new input, f of x is my new input, put that into G. And that's how it works. I won't solve this, I'll just set it up for you. And if you need help with this, go watch the video. Heck, watch the video anyway. So g of x is going to be my input. I'll put that just right here. And then I'm going to put that into f. So we have 2x minus 1 squared plus 3 times 2x minus 1. Now, the thing you need to be really careful about is make sure you're foiling. Don't just square pieces. That's not how that works. So if you need to write it out, foil it, do it, and then distribute this stuff. So you get 6x minus 3. Distribute this and simplify, and you'd be good to go. Okay, I am done covering new material. I'm going to go back through some of the, here's you can see this is the, what I did in the video. So I walked through all of this step by step in the video. So if you would like to see that, go watch that. It's in the test 1 material folder. Okay, Jimmy, I'm going to go back through the stuff we talked about at the beginning before I started recording, so you can skip on out of here. Have a great rest of your Tuesday. I hope to see you on Thursday. And you're welcome. Have a good day. Okay, so I am going to go with the rest of you. I'm going to go through the stuff that I was that I feel like you need to know, just sort of how the course is going to go. So let's see here. I will go first to the syllabus. Okay, so in the syllabus, it's pretty clear, I think. What's different about this than, and I've included this in emails to you guys, is that pre-cal, normally we do not do MML, my math lab. We are going to do my math lab this summer, so that's the biggest thing. This should say homework. That's the biggest thing. So go in and make sure, click on any of the My Math Lab links in Blackboard, and it'll take you to the course where you can choose to purchase the access code or enter one. And now there are 2 options for purchasing the access code. Choose the cheaper one. And so that is that. Graphing calculator recommended. You guys can find those on the internet or wherever if you don't have one. Yeah, and again, the only real difference is that we are going to do homework. So it is included in your grade, and that's going to come from my math lab. Everything else is pretty straightforward. You're going to have quizzes at least weekly, maybe sometimes more than that. That'll be 10% of your grade, and I'll talk through that when we get to Blackboard. Semester exams are 17% each. There's been a, I will be looking for your cheating. I hate that, and I hate that that's been a thing that we have to really be sticklers about, but don't cheat. It makes more work for me, and it makes more work for you, and it's just not, it's not okay. We also know how the internet works, so anyway, don't cheat. Just my advice to you. Okay, and then if you have any questions about syllabus, email me. The schedule, I'm making all this stuff from scratch, so I'm only through test 1 stuff, but as we move into the course, I'll update this and you'll have more information. But so I've laid out how we're going to do the course. We'll spend Tuesday talking about these 2 things and Thursday talking about these 2 things, and then on Friday you'll have 2 sections due in MML typically and a Blackboard quiz due in Blackboard. So I try to write where these things were due so that you'd be able to find them. And yeah, I think that's pretty straightforward. If it's not, let me know. There are a couple times where things are not due on Fridays at 11:59. That's when all of these are due, Fridays at 11:59. And when they're not, I made sure to denote that. So you'll have paper homework due in Blackboard on June 9th and June 15th, and then your test in Blackboard on June 16th. So for right now, the quizzes are going to open on Wednesdays and they'll be due on Fridays. As we get closer to the test, I'll probably make this last quiz especially open for like, I don't know, 40 minutes or something, so that you have this a time restraint, because that's what you'll have on your test. You'll have about an hour and 15 minutes for your test. So there's that. If you have questions about the schedule, let me know. And then let's see. I will share the Blackboard, my screen with you so that we can look at the way things are set up in Blackboard. So in Blackboard, the Test 1 material tab, that's where you'll go, and it has everything sort of laid out in the order that I think you should do them. So there are the blank notes, which I would bring with you to our class meetings. And then there's my completed versions of those notes from when I taught class last semester. No, in the fall. And then there's a video that I made specifically for you guys that walks through a particularly hard example or something that I think is foundational. And then there are links to your Pearson homework, your My Math Lab homework. So the thing, after every 2 sections, you have a quiz, which you can't see right now because it won't be available till that Wednesday, but it'll pop up right in here. Or you can always click on the quizzes tab. Right now this will look blank, but if you'll see, they're all there. They'll just load when it's time. So if this is confusing to you to sort of look at everything in this order, you can look at things individually, like go to the notes, click on the test 1 notes, and everything is in there, or it will be as we like get to the subject. But let's see, videos, they're all here as well, so you can see everything. If you're looking for something in particular, just go there if you don't remember what section it came from or whatever. So there's that, and that's sort of how everything is laid out in the course. You go to the information tab, you can find the syllabus, the schedule, and our home, the home page of our My Math Lab course. So I think that's all that's really important. Again, you'll have quizzes will open on Wednesdays for right now, and they'll be due on Fridays at 11:59. Most of the stuff will be due at 11:59 on Fridays. I will try to send you a weekly, post a weekly announcement about what you have due that we can win, but you guys have got to stay on top of that yourselves. So take that schedule and use it. And if some of you could not get into this because the course tools thing is not showing up, I will figure that out. I know at least one of you is having that issue, so I'm going to go work on it now. But let me know if you have any questions, and I hope to see you Thursday morning